All right, so the power of a test is something that may show up on the AP exam, but it might not. It's not one that's heavily tested or really that is emphasized much, but we do need to go over what it is. You're not going to be asked to actually calculate it from a graph or anything like that, but just being able to understand what it is. So whenever you're performing a significance test, the hope is always to find evidence for the alternative hypothesis. We want to show something that what is being claimed is not necessarily true. That's the idea. Okay? And I mean, the reason for that is usually a sample is taken and it's stating otherwise from the claim. And so we want to prove that that sample is telling us that what's being produced or manufactured is not what was actually claimed by the company. So when you're doing this, researchers can make a type 2 error if they fail to find the convincing evidence, right? They fail to reject the null. So how likely is it to have a type 2 error? Well, we refer to, or to avoid it, to avoid a type 2 error. That's called the power of a test. So the power of a test is a probability that the test will find convincing evidence for an alternative when a specific alternative value of the parameter is true. So in the battery situation, we said the claim is that it's 30 hours. We're hoping that the new batteries is greater than the 30 hours. Well, here what we're looking at is the power of a test to detect that the mean is actually 31 hours. And it tells us that the power of this test is 0.762. So what does 0.762 mean? If the true mean lifetime of the company's deluxe AAA batteries is 31, then there's a 0.762 probability that the company will find convincing evidence for the alternative. Okay, so in other words, we're looking at the probability that we reject the null given the fact that the actual average lifespan of those batteries is 31. That probability is 0.762. So what's the probability that the company makes a type 2 error? Well, it's actually the complement. So power and type 2 are complements of each other. So if you know what the power of the test is, you subtract it from 1, and that's the probability of a type 2 error. If you know what the probability of a type 2 error is, you subtract that from 1 to get the power of the test. Now, what can researchers do to decrease the probability of a type 2 error? Well, you can increase the power of a significance test if your sample size is larger, so increase the sample size. You can increase the significance level, and then also one that is mostly used is that the null and alternative parameter values are further apart. So in the battery example, we had 30 hours, and then we said the true was 31. The further 30 and 31 are apart, so let's say 30 and 35 or 30 and 42, the further those are apart, that gives more power to the test, which means your probability of a type 2 error decreases. Because remember, power and probability of type 2 errors are complements. So as one increases, the other decreases. So if we increase power, we decrease the probability of a type 2 error. So here, we're looking at an Alzheimer's experiment, wanting to test a drug. They claim that fewer than 10% of patients who take its new drug for treating Alzheimer's disease will experience nausea. So we have less than 0.10. So we mentioned that the power of the test here, P, is going to be 0.08 using a random sample of 300 patients and a significance level of alpha 0.05 is 0.29. Determine whether each of the following changes would increase or decrease the power of a test. Explain your answers. So, using alpha, here we go, of 0.01 instead of 0.05 would decrease because Using a smaller significance level would make it harder to reject. Okay? If the true proportion is 0.06 instead of 0.08, that would increase because 0.06 is further from 0.10 than 0.08 is. And then C, using 200 instead of 300 as our sample would also decrease. You want a larger sample in order to increase the power of a test. So, statistical significance is not the same thing as practical importance. To help evaluate practical importance, give a confidence interval for the parameter in which you are interested. Confidence intervals are not used as often as they should be, whereas significance tests are perhaps overused. Remember, a confidence interval gives us an interval of plausible values. That's more information than just saying whether we reject or fail to reject. We can reject it and then give an interval of what this is what the true value actually is. So there's more information given in a confidence interval than there is in a significance test. And so that's why they're saying significance tests are definitely overused. Now, searching data for patterns is certainly legitimate. Performing every conceivable significance test on a data set with many variables until you obtain a statistically significant result is not. This unfortunate practice is known by many names, including data dredging and p-hacking.